Today I'm going to be deriving Vieta's formulas, which are formulas that apply to any equation, and it defines properties of roots. If we have this quadratic equation here, Vieta's formulas can tell us the sum of the roots and can also tell us about the product of the roots, which can be very useful. Let's say we have roots r and s, and we know we can rewrite this equation here in terms of r and s. We can write it in this form. Expand. So we're going to have an a on the outside. This is going to simplify to x squared minus sx minus rx plus rs equals 0. And I can combine ax squared minus r plus sx plus rs equals 0. We want to find the sum of the roots and the product of the roots. So if we have roots r and s, then the sum would be r plus s, and the product would be r times s, or rs. And we see those exactly here. So let's distribute the a. Negative a times r plus s. And how are we going to find this? Well, we have to set it equal to something. And if we expand out this equation, then this term here, where x has a degree of 1, is going to correspond with bx up here. So b. And then r plus s equals negative b over a. Similarly, we distribute a here. A times rs, this corresponds to the integer part because the degree of x is 0. So that corresponds to c. Therefore, the product rs is c divided by a. And this is true for any quadratic equation. The sum of the roots is always going to be negative b over a, and this product of the roots is always going to be c over a. And now we know why this is true. But does this also work for equations whose highest degree isn't 2? Like, what if it's a cubic equation, or a 4th degree, or 5th degree, or nth degree? Does this work? The answer is yes. Let's take a look at another one. So again, let's just say we have roots r, s, and t. So we can rewrite this as a times x minus r times x minus s times x minus t equals 0. So then again, if we expand this, I'm going to expand these two first. And we know that from previously. It looks like this. And then times x minus t equals 0. So now let's expand. A times, this is just going to be x cubed, and then this will be minus tx squared. Then this part will be minus r plus sx squared. This would be plus, because there's two negatives, plus tr plus sx. This would be plus rsx minus rst. And that should equal 0. I can combine some like terms. So we have a out front and then x cubed, and then I can combine these blue terms because they are both multiplied by x squared. I can rewrite this as r plus s plus t x squared. And then I can combine the red terms. So this would be rt and st. So rt plus st plus rs x. And then finally we have this term, minus rst. This is equal to 0. So again, we find some patterns. This blue part, can't forget to distribute the a, but this would be negative a times r plus s plus t equals, and this term is x squared, so that corresponds to b. Therefore, the sum of all three roots is negative b over a, which is similar to what we had previously in the quadratic equation. Now, this red part, since it's just x with a degree of 1, that corresponds to c. Again, if we distribute the a, we get a times rt plus st plus rs equals c. So rt plus st plus rs equals c over a. And then finally we have this. So distributing the a, we get negative a times rst equals, and this corresponds to d. So rst equals negative d over a. Cool. So we figured out the formulas for the sum of all three roots, the sums of the products of any two roots, and the product of all three roots. And you can also notice that the signs of the formulas alternate. So what I mean is, this is negative b over a, this is technically positive, and then this is negative. So it alternates. If we look back here, the sign also alternates. And the same is going to happen if you have a fourth degree or fifth degree. The signs will alternate. So that is also interesting and something helpful to remember. And it's also very useful to remember Vieta's formulas for a quadratic equation and a cubic equation. So yeah, that's Vieta's formulas. I hope you learned something from this video, and thanks for watching.